All right, welcome. So we're going to finish this up if you're interested. If you feel like you've got the piecewise thing all figured out, then do not watch this unless you really just like listening to my voice. Okay, so again, please try and do these problems for any of these for your notes. It'll help you a lot more if you give it a try first and then make mistakes and understand the mistakes, okay? That will help you so much more. Okay, so here we need to write down our domain lines. Okay, it's basically just your numbers that are on your right side. So here we have one at -4. So I'm going to do my dotted line thing here. It's a little easier. So here at -4. And then we also have one at 1. So for our first function, I'm going to call it 1. That applies to this domain. Okay, it goes from -4 to 1. And then the other function applies to number 2, and we'll call it number 2. Okay, and we want to graph those. So for the first one, this is an absolute value function. This is for our vertex. It gives us -3, 1. So we'll plot that, -3, 1. And then we need to use the slope. So the slope here is a -2 over 1. So we go down 2 over 1. It's just your rise over run. So down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. And we mirror it to the left side. So these should always look something like a V. And then we need to write down the domain. So on the left side, it's just x is greater than -4. It's not equal to. So here we need to have it be open. And then on the right side, it includes negative or +1. So we'll fill that in. Okay? And then our other function is a quadratic. It's also in vertex form where h is 2 and k is 0. So our vertex here, I'll write it over here, the vertex is 2, 0. So 2, 0. And then we'll use our growth pattern. Here a is 1, so we go over 1, up 1, and then 3, and then 5. Okay, and then we'll connect those dots best that we can. That wasn't the best I could do, I'm sorry. And then we need to look at the end behavior. So when it's only when x is greater than 1, so it does not include that, so we'd leave it open. Okay, and then here's E. Again, we want to write down our domain. So this one, we just have one domain, a line that's at 0. So I'll draw that here. And then we'll plot our functions. So we'll say this is 1, and that's when x is less than 0. So we'll do that first. It says vertex form. Our vertex here would be 3, -5. 3, -5, which is right here. And then we use our growth pattern. Again, here a is 1, so we go over 1, up 1, over 1, up 3, over 1, up 5. Connect those dots the best you can. Again, if piecewise function or graphing is still kind of an issue, again, you can always graph these individual equations. Use the second graph and do a table to find these points. Okay, and that does not include when x equals 0. So this should be an open hole. And then we'll do our other equation. So this one is also in vertex form where h is 0 and k is 5. So 0, 5, which would be right here, is our vertex. If I did that right, I think so. Yes. And then we'll use our growth pattern. So A is negative 2. So 1 times A, 3 times A, 5 times A. That gives you negative 2, negative 6, and negative 10. So we'll go over 1, down 2, over 1, down 6, and then 10 would get outside of your graph. So it's something like this. Okay, and then it includes 0, so it should be a filled-in dot. Okay, so that's it. Hopefully that helped if you needed a little extra. Again, if you have any questions, please let me know. We'll see you later.